Okay, I let the dog upstairs, so now he is occupied. All right, so like I said, here in section 3.3 of chapter 3, all of a sudden he brings up dummy variables. I'm not real sure why in this chapter, but really useful stuff. All right, so let's say you're doing a study on grades again, all right? Let's do grades again. And let's see, you're trying to explain grades as a function of hours, all right, hours of study. And you're also wondering, actually, I wonder if I should also take into account the different culture between male and female students in college, in the sense that there is a potentially somewhat anti-intellectual bias among the guys. I don't want to look like I'm too smart. I mean, it's not quite as bad as high school, but nevertheless, whereas the female students are like, I want to make a good grade. And I don't know if you're aware of this or not, but the average female GPA is, and has been for many years, higher than the average male GPA. So you're thinking, I want to take both of these into account. Oops, forgot I didn't finish erasing before I chased the dog off. All right, so you've got here, grade equal to beta sub 0 plus beta sub 1, hours plus beta sub 2, female, I found my pen here. All right, yeah, here it is. Let's make this the theoretical equation, so I'm going to have a plus stochastic error over there. Sorry about that. Let's see, sub I, sub I, sub I. Okay. That's a plus sign right there, because it fell off the edge. Now, let's see. And note here, what you're thinking to yourself is, it's not just that the female students study longer, because that would be picked up right there, all right? You don't need an extra variable if it's just that they study longer. You're thinking, I believe it's not only that they study longer, but they study more efficiently. They're really focusing when they study, all right? When the guys are sitting around studying, they're doing so with the TV on and in the middle of taking breaks from playing a computer game or whatever, whereas the female students are focusing, all right? So you think it's above and beyond the number of hours, right? You don't know if it's true or not. Maybe you're putting this together and you're trying to find out, is beta sub 2 actually going to be an important variable here? All right. But this is easy. We measure this in number of hours. How do you measure male versus female? Well, you use a dummy variable, because a dummy variable takes on two values, either 1 or 0. All right? And you can set 1 is equal to male and 0 is female, or you can set 1 is equal to female and 0 is male. It does not matter at all. All right? So you just got to pick one or the other. I decided I'll go with 1 equals female and 0 equals male, all right? So, and then you run a regression with this. And so it's a very easy column to create as you put your data together. One of the columns is simply 1, 0, 0, 1, 1, 0, 1, 0, 1, whatever that particular student, whether they were male or female. Now, check out what this does, and I got a couple of things I need to go over here for you. Check out what this does to the regression. Let's see here. Let me write it above there. All right. When female grade is equal to beta sub 0 plus beta sub 1 hours plus beta sub 2. And I'm going to leave off the stochastic error term right here, if that's okay. Apologies to those who are big fans of the stochastic error term. All right. So if for this particular observation, all right, this for all the female observations, on the female observations, that is always a 1, right? And so beta sub 2 times 1 is simply beta sub 2. That's all it is, all right? Beta sub 2 times 1 is simply beta sub 2. So look, what we've really got here, let's rearrange it just a little bit. What we've really got here is a different intercept. what we've got is a different intercept. This is called an intercept dummy. There's an intercept dummy and a slope dummy. We'll do the slope dummies later in the semester. But this is an intercept dummy. So when the student is female, the regression line is going to have a different intercept. I'll illustrate that here in a minute. But right now, just think about that for a second. Look, if for this particular observation, it's a female, then that's beta sub 2 times 1. So it's just beta sub 2. And so, well, really, that's just another constant. We've got beta sub 0 as a constant, and beta sub 2 as a constant, and the constant is, of course, the intercept. So we really just have a different intercept for female students than for male students. For male students, now what if this is male? When male? In that case, let me make sure everything's nice and legible. It's actually not right now. Oh, because it's focusing on me. Let me get out of the way. Yeah, there it goes. Okay. I better be careful. Although looking back at the other videos, it seemed to do okay. But for just now, that was really out of focus. All right. Grade is equal to beta sub 0 plus beta sub 1 hours plus beta sub 2 times 0. Right, so for a male student, what we've got here is grade is equal to beta sub 0 plus beta sub 1 times hours plus beta sub 2 times 0, right? So obviously this is just going to, purple. That's just going to fall out. So what we've got is grade is equal to beta sub 0 plus beta sub 1 hours. So, and let me circle that as sort of the final equation there, and I'll circle this one up here. So the difference between the male and female regressions here is going to be the intercept. For a female student, the intercept is beta sub 0 plus beta sub 2. And for a male student, the intercept is just beta sub 0. That's it. So, what we're saying here is then that if you're female, you simply get that much higher grade. Presumably, we haven't run the regression. We're assuming at this point it's going to be a positive number, could be a negative number. But the difference is we're assuming that if you're a female student, right away, immediately, we have to figure you're going to make beta sub 2 higher on the test. All right, let's say it's 15 points out of a 100-point test. If you're female, immediately you're making 15 points higher. And why is that? Even independent of the hours of study, then our theory here is that women take the classes more seriously. They're not missing. We don't have any data for attendance. Let's say we don't have any attendance data. Well, they come to class, they keep up with the assignments, they keep up with the reading, and when they do study, it is a more efficient form of study, which actually would be better as a slope dummy, but we'll talk about that later. So, just being a woman means you're going to get a higher grade. How much? Beta sub 2. Or it could be just being a woman gives you a lower grade. How much lower? Well, whatever this number is right here, which in that case would of course be negative. Let me illustrate that. Let me see if I've got this drawn out here. Yeah, I do. Yeah, I do. All right, let's see here. As a matter of fact, it works for exactly what we just did. All right. This is in the book. It is, in fact, figure 3.3. And what it's showing is that since in this regression equation, we are assuming they both have the same slope. Look, they both have the same slope. The slope is beta sub 1 in both of them. All right, so beta sub 1 in both, same number. So beta sub 1 is the slope in both of these. So it has the exact same slope. The difference is the intercept. And of course, if we were using the example I just went over just now, for women it would be the regression line on the top. For men it would be the one on the bottom. So check this out. Let me kind of sketch this on here real quick. Erase, erase, erase. Okay. There's your hours of study. Here's your grade. and there's your two lines. Both of those have slope equal to beta sub 1, right? And let's say this is women, men. I'm not going to write the equation out. So this intercept is beta sub 0, and this intercept is beta sub 0 plus beta sub 2. All right, that was that coefficient that we put on the dummy variable for gender. Now, let's say that you know that someone has studied 10 hours, and you're trying to predict what grade they would earn. Well, if they were male, you'd figure, oh, they're going to earn this grade. Let's say it's a 70. I don't know, 70, right? And I'll write 70 there. They said, but if it's a female student, they're actually going to earn an 85, all right? Where clearly what I'm assuming here is that beta sub 2 is equal to 15, all right? So for a male student studying 10 hours, my regression analysis is predicting, oh, and by the way, I should put hats on all these because this is clearly a regression that we ran. Well, that's not necessarily true. I could be talking about the theoretical equation. But let's say I'm not. Let's say I'm talking about the one I ran. Then a text from Melanie. Okay. So if somebody studied 10 hours, and so if it's a guy, you're going to get a 70, but if it's a woman, you're going to get an 85. Why? Because we have assumed that just by being a woman, you are coming to class and so forth, and you end up with a higher grade. That's kind of neat. Now, the last thing I need to point out here, very, very useful, dummy variables are. The last thing I want to point out about this, and that's the end of this chapter, is that something you don't do is include two dummy variables here, right? You don't need this. Grade is equal to beta sub 0 plus beta sub 1 hours plus beta sub 2 female plus beta sub 3 male. Where this one's equal to 1 if you're female, and this one's equal to 1 if you're male, and of course 0 if you're female. Well, we just did the same thing twice, all right? There's no need to include male if we've already got female. If we've got a 0 under female, that must be a male, all right? And in fact, these two columns would simply be mirror images of each other. Everywhere this was a 1, this would be a 0, and everywhere this was a 0, this would be a 1. All right, so not only is that redundant, but actually the regression won't even run. The computer, and we'll cover this in chapter 8, I believe, 8, multicollinearity. The computer will say, I can't tell the difference between these two numbers. Now bear in mind, the computer has no idea what these numbers mean, all right? The computer doesn't know, oh, that's female and that's male. Okay, I understand what's going on here. It has no idea. All it knows is there's a column of zeros and a column of ones and zeros and ones where the places are reversed. It's going to say, I can't tell the difference in these two variables. For all intents and purposes, they're the same variable, except that when one is a 1, the other is a 0, all right? So I can't even run the regression. You're asking me, human being, to estimate beta sub 2 and beta sub 3 for you. I can't even tell the difference in these two variables, so it won't run. It will spit back a result that says that your regression has perfect multicollinearity and you can't run it. So with a dummy variable, you always, and this could be more than two conditions. It could be, it could be 3 different states. It could be Texas, Oklahoma, and Louisiana that we're interested in. And, we also want to know, are you from Texas, are you from Louisiana, or are you from Oklahoma? We only need 2 dummy variables for that. One that's 1 or 0 for Texas, one that's 1 or 0 for Oklahoma, but we don't need one for Louisiana, because if you got a 0 here and a 0 here, well, that must mean Louisiana. That's what's left. So you always do one fewer dummy variable than the total number of conditions that you're actually testing, all right? All right, neat stuff. That's the end of chapter 3. Au revoir.